in the floor when I open the door for her. She acting like a whore and I'm a letter. Learn from Project Patch.
Okay, number 3, we're asked to solve each inequality, or this inequality right here. So on the left side we see some kind of factored polynomial, right? And then it's less than 0. So our job here is to find, okay, what are the horizontal intercepts, first of all, of this polynomial? And then we're going to find on which of these intervals is our function less than 0. On which intervals is our function negative, basically. Okay? So the first thing we're going to do is pretend that this polynomial is equal to the right-hand side. So that would be equal to 0. Okay? So if we pretend that, we're just going to find our horizontal intercepts, or our roots, and that would be x equals positive 1, x equals negative 2, and x equals a positive 3. Okay? So now I'm just going to do the method of the sign analysis, sign as in S-I-G-N, sign analysis. Okay, and to do that, I just draw a number line. Okay, this is an x number line. And then we just plot our zeros in order. Okay, so negative 2 goes here, a 1 goes here, and a 3 goes here. We pick test points in between in each of these intervals created. Right, I'll just draw like lines here to show you what the intervals are. Okay, and that one's going through 1. Okay, so on the left side we could have, well, negative 3 could be our test point here. 0 is our test point in there. 2's in here. And how about 4 over there? Okay? So for each of these, we're just going to plug in these test points, the ones that I circled, into our function. We'll just call it f of x, okay? That's like our polynomial. So f of negative 3 would be equal to negative 3 minus 1 times negative 3 plus 2 times negative 3 minus 3, okay? And the thing is here, we don't have to worry about specific, like, okay, did we get a 4 or a 6 or any kind of like actual value? We just need to know what is the sign, like positive or negative, of our answer, okay? So here we can just say, okay, so this is definitely going to be negative right here. That's negative 4. But it's negative, this is negative, and this is negative. So overall, 3 negatives make a negative, right? So we're just going to stick a negative sign right up here for this interval right there, okay? Now let's do the same thing with the other 3 test points. So f of 0 is equal to 0 minus 1, 0 plus 2, and a 0 minus 3. So again, we can say, okay, so that first thing, this first group is going to give us negative, this is going to be positive, and that's negative. So this turns out to be positive, right? So we put a plus sign right in there. So we're done with that interval. Now let's do f of 2. This gives us 2 minus 1, 2 plus 2, and 2 minus 3. So both of these first ones are positive, positive, and the other one's negative. So this turns us negative, okay? So we're done with that interval, and for the final one, we just have f of 4 is equal to 4 minus 1 times 4 plus 2 times 4 minus 3, and these are all going to be positive, okay? So we just get positive for that last interval here. Okay, so now we're done with sign analysis, and we just have to pick, okay, what, depending on our inequality, the one that we want our function to be less than 0, right? So in order for us to be less than 0, we just have to pick the negative intervals here, okay? And they can't include 0, right? Because we don't have that or equals to sign. So we can't include the endpoints, alrighty? So ultimately, our intervals are going to look like this. So this interval, the way we write that in interval notation, is negative infinity up to negative 2 non-inclusive. So we have a rounded bracket. And we also have this kind of U means union, so that just means also another solution is the interval from 1 up to 3. Okay, and again, rounded brackets because we don't want to include those endpoints. Okay, because we don't want an exact equality to 0. Alrighty, so that is our answer for number 3. Okay, number 4 is kind of similar, but it gives us a little different application of solving a polynomial inequality. So what we're going to do is find the domain of this function here. So again, we see something like, okay, some function has a square root of something else. So we know about square roots, they must be, whatever's inside must be greater than or equal to 0, right? So this gives us our polynomial inequality, because now we can set everything inside greater than or equal to 0, because that'll give us the domain, right? So in order to solve this, again, we kind of consider this an equality, an exact equality, first of all, to figure out what's going on with our polynomial, right? So the zeros we obtain are x equals 3, and x equals to -2, right? And then with those, we can do sign analysis. Okay, so let's do that real quick. Okay, so we plot our zeros here, so -2 and +3. We can pick our test points, so we could say -3 is in here, 0's in here, and 4's over here. Okay, and now we just plug those into our polynomial. So we could say, okay, so for -3, we get -3 minus 3, and then -3 plus 2, but squared. So anything squared is always going to be positive. So this second term is always going to be positive. And then we have a negative, so that turns it negative. Okay, so we have a -1 here for that interval. How about, let's try 0. So 0 minus 3 times 0 plus 2 squared. Again, this is always positive, and this is going to be a negative. So again, we get a negative, right? So negative again. Now let's try 4 lastly. So 4 minus 3, there we go, that's positive. And then 4 plus 2 squared, that's definitely going to give you a positive value. Okay, so the one that we're going to pick, the interval, we want this to be greater than or equal to 0. So we're going to pick the positive interval right here, going from 3 to positive infinity. Okay, and that's basically going to be it. And we're going to include that endpoint, so 3 to positive infinity, because we have this or equals to on the bottom there. Okay, so that means we can include the point which gives us the 0 as well. Okay, this can also be notated as x is greater than or equal to 3. Either of these are okay to list the domain of our function.
Money make a crowd go down.